The James Webb Space Telescope has made a significant observation by detecting a high redshift galaxy that dates back to the early universe, beyond the previously established limits of observation. This galaxy, which emerged only a few 100 million years after the Big Bang, is notable for having a supermassive black hole. This discovery disrupts existing theories about the formation and evolution of galaxies, indicating that early galaxies were more massive and developed more rapidly than previously thought. These findings are leading scientists to reconsider current models of cosmic evolution. To learn more about the implications of this discovery, watch the video till the end. Before we dive into JWST's findings, let's first understand what the Dark Ages were. This era started about 380,000 years after the Big Bang, which is when the universe first cooled enough for hydrogen atoms to form. This time lasted until roughly 1 billion years later, when the first stars and galaxies began to appear. During the Dark Ages, the universe was filled with neutral hydrogen gas. This gas was so dense that it blocked most visible light, making it nearly impossible to see what was happening in those early cosmic times. Scientists had always believed that this period was a time of complete darkness, with very little light reaching us from these early epochs. Now, let's talk about how JWST has changed everything. The James Webb Space Telescope is equipped with advanced instruments designed to look further back in time than any previous telescope. Its powerful infrared capabilities allow it to see through the dense cosmic fog that once obscure our view of the universe's early stages. Recently, JWST achieved a major breakthrough by detecting an object from the Dark Ages, a feat that was previously thought impossible. This finding is turning our understanding of the early universe on its head. One of JWST's most exciting discoveries is a high redshift galaxy from this era. High redshift refers to light that has stretched to longer wavelengths as it traveled across the universe. This stretching happens because the universe is expanding. The fact that JWST detected this galaxy means it is incredibly distant and dates back to when the universe was just a few 100 million years old. By cosmic standards, this galaxy is extremely ancient. Its light has been traveling for billions of years to reach us, giving us a rare glimpse into the early universe. The James Webb Space Telescope's recent findings have uncovered a supermassive black hole within an ancient galaxy, a discovery that has surprised many scientists. For a long time, it was believed that supermassive black holes could not have formed so early in the universe's history. According to previous models, these massive black holes were thought to emerge much later as galaxies developed over time. However, finding such a black hole in a galaxy from the Dark Ages challenges this notion. This discovery indicates that the early universe's galaxies were more complex and evolved at a faster rate than previously assumed. The presence of a supermassive black hole so soon after the Big Bang suggests that the processes leading to galaxy formation and growth were much more dynamic. It implies that the early universe was a period of rapid development and significant activity, contrary to earlier beliefs of a slow and gradual buildup. This new evidence forces scientists to rethink existing theories and models about how and when these colossal structures came into being. Overall, the discovery of this supermassive black hole is reshaping our understanding of cosmic evolution during the universe's earliest epochs. JWST also detected Lyman alpha emissions from this galaxy. Lyman alpha emissions are specific wavelengths of light emitted by hydrogen atoms when they become excited. These emissions suggest that light was able to pass through the dense hydrogen clouds of the Dark Ages. Additionally, JWST observed ionized hydrogen bubbles around the galaxy. These bubbles formed when radiation from the galaxy's early stars ionized the surrounding hydrogen gas. This discovery shows that the universe was not completely opaque during the Dark Ages. Instead, there were regions where light could penetrate, altering our previous understanding of how light and matter interacted in the early universe. JWST's findings are challenging long-held cosmological models. Scientists previously believed that the Dark Ages were a time of total darkness and that galaxies formed and evolved much later. The discovery of an ancient galaxy with a supermassive black hole suggests that these models may need significant adjustments. The evidence that early galaxies were more massive and evolved faster than previously thought is changing our view of cosmic history. The universe's early stages appear to have been more active and complex than earlier models predicted. JWST's discoveries are likely to inspire new studies and observations. Scientists will need to refine their models of how galaxies formed and evolved to account for the surprising features of these early cosmic structures. Future missions and telescopes will build on JWST's findings to further explore the mysteries of the early universe. This could include more detailed investigations of high-redshift galaxies, the role of supermassive black holes, and the overall structure of the cosmos during its early years. In summary, the James Webb Space Telescope has provided us with a view into an ancient galaxy from the Dark Ages, revealing a supermassive black hole and detecting key emissions that challenge our current understanding of the early universe. These findings are prompting scientists to rethink their models of cosmic evolution and suggesting that the early universe was more dynamic and complex than previously imagined. As JWST continues its mission, we are on the verge of uncovering even more about the universe's earliest epochs. Thank you for joining us on this exploration of JWST's remarkable discoveries. Share your thoughts and questions in the comments below, and we'll see you in the next video. If you found this video informative, be sure to like, subscribe, and hit the notification bell for more updates on the latest in space science and astronomy.